Alright, so we're doing exercise 5b, and in this video I'm going to be answering 8a. So let's read it. Sketch the graphs of each of the following relations, stating the maximal domain and range of each. So we've been given y equals 2 over 2x minus 5 plus 3. So as you can see, I've broken it down into 4 steps. First, we're going to find my asymptotes. Then we're going to find the x-intercept. Then we're going to find the y-intercept. And then we'll sketch it and write down my domain and range. So hopefully upon seeing this question, you immediately recognize that this is a rectangular hyperbola, which means it's going to have asymptotes. So let's now find them together. So the very first thing that we're going to take note of is the fact that if my denominator here was 0, that would mean that the entire thing would be undefined. So I want to find the value for which this is going to occur for x. So in other words, let me write it out. I'm going to have 2x minus 5 equals 0. So I want to know the value of x for which this is going to equal 0, because that is going to be my asymptote. So now if I was to do some rearranging, I'll get that. So I plus 5 to both sides, and now I'm going to divide 2 from both sides. It's going to be 5 over 2. So this means when I put 5 over 2 into my x spot, it's going to mean that 0 is going to be my denominator. So 2 times 5 over 2 is going to be 5, and 5 minus 5 is 0. So we know that x equals 5 over 2 is going to be my first asymptote. It will be a vertical asymptote. So let me highlight that. Next, we're going to find what my horizontal asymptote will be, which is far easier. And we know it's simply going to be this. It's going to be y equals 3. So let me write that down. So my other asymptote is going to be y equals 3. Perfect. So let's now come over here and put both those spots on. So I'm going to put in x equals 5 over 2, because at that spot, my graph will be undefined, and so too for y equals 3. So now I come over here to my graph. Let me zoom right in. So I know that x equals 5 over 2 is going to be 1, 2, it's going to be right here. So I put in a dotted line. And then I say this is x equals 5 over 2. And let me actually put this on this side. Well, let me put it down here. Perfect. Next, my other asymptote is at y equals 3. 1, 2, 3. It's going to be right here. So I put in these dots. And I write y equals 3. Perfect, so I've put both my asymptotes in. So let's now move to my second step, which will be finding my x-intercept. So let's have another look at what my question is. So I'm now going to simply write this down. It is y equals 2 over 2x minus 5 plus 3. Now to find the x-intercept, we let y equal 0. So I'm just going to get rid of that. So sub 0 into my y spot, and now solve for x. So the first thing I'll do is minus 3 to both sides. Next, I'll times 2x minus 5 to both sides, so I'm going to get negative 3. 2x minus 5 equals 2. Then I'll expand out my brackets. I'll get negative 6x plus 15 equals 2. I'll then minus 15 to both sides, so I'll get negative 6x equals negative 13. And then finally, I'm going to go x equals 13 over 6. I divided both sides by negative 6. So that is going to be my x-intercept. 13 over 6, which is going to be 2 point something. It's going to be 2.1666. So I'm going to come over here and say that my x-intercept is going to be 1, 2, it's going to be here. And as always, I'm going to put in what that is. It's going to be 13 over 6 and 0. Let me come and now find my y-intercept. So again, for my y-intercept, I'm going to begin by writing down what my graph is. It's y equals 2, 2x minus 5 plus 3. So now to find my y-intercept, I'll let x equal 0. So it's going to be y equals 2. I'm going to put a 0 in there. 2 times 0 is 0. So I'm just going to get minus 5 plus 3. I want this 3 now to have the same denominator. So I'm going to go y equals, now that negative, let's not get too freaked out, the negative's in the denominator. That doesn't mean anything. This whole thing is negative. So that is going to be 15 over 3. So that means, oh, whoopsie daisy, over 5, my mistake. So that's going to be 13 over 5. Because negative 2 plus 15 is 13. So it's going to be 13 over 5. So now 13 over 5 is once again going to be 2.6. So I could come over here and get a pen and say 2.6. Well, this is 3, 1, 2, 2.6 is going to be about here. And I make sure I label it. So I'm going to go, that is 0, 13 over 5. And now I have everything I need to sketch this now. This is now the hardest part, which is sketching. So hopefully you're all wishing me luck. It's going to look like this, then go down. That is horrible. Let me try again. There we go. The trick is short little swipes. And it's going to go this way as well. It's going to go this way. So that should be a bit more smoother. I'm sure you can draw this better than me. It's quite hard to draw this on the tablet. All right, so now I have my graph. I have my intercepts. I have my intercepts, one here and one here. I have my asymptotes. So now I should be able to tell you what my domain and range is. We know that my domain is going to be the set of all possible r values. And as you can see here, it's going to exist for all my x values except here, except for when x equals 5 over 2. So what I'm going to say is going to be all real numbers except 5 over 2. So it's all real numbers except for this spot, because at this spot my graph isn't defined. Then for my range, it's going to be the exact same logic, but now thinking of my y values. My y values are going to exist everywhere except at y equals 3. So I'm going to say it's all real numbers except for 3. So there you go. We have now answered question 8a. It was quite long, but hopefully this has enabled you to answer it successfully and you've understood all the ideas in it.